properties of logarithmic expressions. Okay, so properties in math, if you guys think about when you first learn properties of multiplication and addition, their properties are the same. Like in multiplication, 4 times 5 is the same as 5 times 4. It's the same thing with addition. 4 plus 5 is the same as 5 plus 4. So multiplication and addition typically have the same rules, same properties, just like subtraction and division do. So it would make sense. Okay, this side right here, all of these right here are the condensed versions. Okay, that's when they've taken multiple logs and put them together as one log. The right side over here, all of this stuff, these are the expanded versions. So it would make sense that on a problem, so look up here, on a problem where you see two things being multiplied together in the condensed version, in the expanded version, when we separate them, what symbol goes between them? We're going to add them together, okay, because multiplication and addition have the same properties. So this is what we call the product property. If two logs have been condensed using multiplication and you are told to expand it, you will separate them and just put a plus sign between them. Now, if you have the expanded version like this, seeing that plus sign should say to you, okay, well, if it's addition here, when I condense it, I'm going to actually just multiply these two together and just make it 1. Same thing is true with division and subtraction. So for the quotient property, quotient means divide. If on the condensed version you see division, then when you expand it, you're going to just put a minus sign between them. You're going to separate them. You're going to have this one first, then this one, and there will be a minus sign between them. Because again, division and subtraction go hand in hand. The only one that's a little different is down here. It's the power property. So if you see something like one single log where it has been raised to a power, and you are told to expand it, where does that power move? To the front. So this is an exponent. The exponent moves out front and it just becomes multiplication. Like the number, the exponent goes here, and that means this times the log. Okay, just like if you had expanded and you see a number out front, when you go to condense it, all you do is you take this number and you just make it the exponent of whatever we were finding the log of. Okay, so this entire lesson is all about condensing and expanding. You won't need a calculator at all. I am going to give you examples where this is, look down here. These have been expanded. How do I know? Because there's more than one log, right? So these are the expanded versions, and we want to condense, which means we want to make this, we're going to make it just one single log. So we have to use those properties to put these together. Okay, so starting with this one. When you see addition, what's it going to turn into? Multiplication. So this number times this number. And all you would do is you just write the word log once, and you'd write the base once. They both had a base of 7, so we're allowed to do this. And then in parentheses here, I don't really need you guys to do the multiplication. Like, you don't have to tell me what 2 times 4 is. Yes, I know it's 8. But I'm not testing you on, do they know what 2 times 4 is? I'm testing you on, do they know that addition gets turned into multiplication? So I just leave mine written as a multiplication problem because, in all honesty, it's usually not going to be 2 numbers. A lot of times these might be 2 letters, or it might be like 7 times x. So it's not like you can even really multiply them out to get a whole number anyway. The one next to it, still addition, all of them are addition. So now there's 3 single logs, but we're still going to condense it down to just 1 log. So I write the word log, I keep the base the same, and then in parentheses, what 3 things do we multiply together? 5 times 6 times x. Okay. Now, in this next row, these two, you see minus signs. So when you see minus signs, we should be condensing it and turning it into what? Division. So we're going to do log base 4. Then in parentheses, what 2 things are we dividing? 12 divided by 4. So this divided by this. And yes, I know 12 divided by 4 is 3, but you don't have to do the division, just leave it alone. Then this one over here, log base 3. 7 divided by y in parentheses. See, there's an example where you wouldn't even be able to do the division anyway, so that's why I just leave it as a division problem. I don't actually do the division or the multiplication, even if I can. Okay, so this one up here, the first row, that was the product property. The middle row was the quotient. This bottom row, these are the powers. So right now, when you look at these, I see a number in front of the word log. When I see that, I immediately I think, okay, that number out front needs to become the exponent of whatever I'm finding the log of. Four to the second power. Yep. Now, because it's base 10, technically you don't have to put the 10 there, but I did tell you guys yesterday I typically write it anyway, because when we solve equations that have logs, you need to know what the base is. So then the other one, log base 6 of x to the third power. So we're just taking that 3, putting it here as the exponent. We took the 2 and put it there as the exponent. So now that's one single property. Okay, so when you guys turn the page, we're gonna do some more condensing, but there are going to be multiple properties within each problem. Okay, so if you guys look at, I'm going to try to break this apart here so we've got some room. This first example, we have subtraction, which means this will be divided by this, right? However, there is a number out front of the first log. This number will become what? The exponent of x, right? Not the exponent of the 4, because the log of 4 is separate. So now our division problem, x to the 5th power over 4. Yep, exactly right. This one over here. We've got addition, which means the n and the m are going to be multiplied together. Okay, so could you guys look at the board, please? I know I have log base 8. I know I'm going to take the n and multiply by the m. However, there are numbers in front of both logs, which means each letter should have its own exponent. So the n is n to the third, and the m should be m squared. You guys okay with those? Properties. Okay, now this one here, we got several things happening. We have this 3 will become the exponent of the 2, right? Yeah? Then these first 2, because of the addition, won't those be multiplied? Okay, so I'm going to start with the log base 10. Now in parentheses, okay, you guys kind of have to think ahead, so please look up here and watch. 2 and 4 are going to get multiplied together because of the plus sign, and the 2 is going to have an exponent of 3. But then as soon as you see this minus sign, doesn't that turn into division? So we need to make sure that we have a fraction bar. 2 to the third times 4 would go up top, because that's the plus part. And then what goes on the bottom? Just the 16. And then that one's done. Now, if you hadn't noticed, every problem we've done so far where we were condensing, every individual log had the same base as all the others, right? That's why we're allowed to do it. So right here when it says critical thinking, could you write this as a single log? What do you guys think? Can I condense that? Do they have the same base? Okay, but they don't have the same base, right? If they don't have the same base, we can't combine them. We can't condense them. No, you can't. That's different. You cannot use these properties to condense unless their bases match. If their bases are not the same, you cannot condense them. So we would say no, bases are different. Yeah, both of them would either have to be a base 2 or a base 6. Okay, so that first part that we just finished, that's all about condensing. That's taking multiple logs, condensing down to one single log. Now we're going to go the other direction. So now we're going to give you something that has already been condensed, and you guys are going to have to expand it. Okay, so this is my thought process. I see two things being divided. So immediately I'm like, okay, I'm going to have 2 logs, and it better turn into subtraction, because division, when you expand, you put a minus sign. So the first log would be log base 5 of x, right, because that was the numerator. Then I would put a minus sign since it was division, and what would my second log say? Of y. Yep. And that is correct. Okay, this one here. So 3 times r, right? So it is multiplication. So when we do our 2 logs, multiplication gets turned into addition, right? And doesn't the r have an exponent? So isn't there also the power property here? And when you have an exponent, where will the exponent move? Up front. Okay, so my first log is log base 10 of 3. Then I would have the plus sign. Now when we do the log of r, so you might want to be watching, you have log base 10 of r. I cannot leave that as r to the 4th. I have to take that exponent and put it right here. The 4 would only go in front of the log of r because it was attached to the r only. And then whenever you're ready, you guys can turn the page, and we only have 2 more to go. Now these are going to be a little bit trickier. Oh. Okay. So, look right here. Oh, right there. The C is being multiplied by the radical, right? So we know that since we see multiplication, we will turn it into addition. The other thing we need to talk about is we know that this is C to the 3rd, but we need to write this A with an exponent. So I want you guys just to think about what we did. Man, I don't even remember what day it was. But if we had a root of 3 and I said, let's take radical form and put it in exponential, A would be the base. What would our exponent be as a fraction? Because the root goes on the bottom. What number would go up top? I can't hear you. It is a 1. You're right. It's A to the 1/3. Yeah. Well, it's important to know that because technically what this means is they had C to the 3rd times A to the 1/3 power. That is crucial because we have an exponent on A that will have to move out front of the log of A. This is a 9 because that's the base. Okay, so let's separate these. We have the log base 9 of C. Where is that exponent of 3 going? Where do we put exponents? In the front. So it goes out front of that log. Then multiplication gets turned into addition. Now this exponent would have to go out front, right? So I'd have 1/3 times the log base 9 of A. And then we have 1 more to go. Okay, right here, this y, this cubed root of y, it'd be y to the 1/3 power. So we have, originally what we had here was x to the 5th times y to the 1/3, and then all of that divided by 4. So it appears to me that I'm going to actually have 3 logs this time. I'm going to have the log of x, the log of y, and the log of 4. We've got 3 different pieces. But since this is multiplication, what is the top going to turn into? Addition. So when we go to do the log base 2 of x, the exponent of 5 would go out front. We'd put a plus sign, And then when we focus on the y, wouldn't the 1/3 go out front? And then log base 2 of y. We've gotten x and y taken care of. What about the 4? Is that going to be plus or minus? Of 4. Good job. Yeah, the 4 did not have an exponent on it, so you didn't have to put a number out front of that log. However, these two had exponents, so the log of x should have a number out front and the log of y should have a number out front. The log of 4, there's no exponent, so it's just log base 2 of 4, but since it was division, we had to turn the division into subtraction, and we turned the multiplication into addition. So there were 3 separate logs there, 2 of them being added together and then doing subtraction. And that's the end of the first video. That one was shorter than yesterday's. Hang on.